Good morning, student. Today I'm going to discuss with you the analytical method on a system of coplanar forces acting upon a rigid body at different points, which can be reduced to a single force together with a couples. Regarding theorem 2, this is in analytical method how we solve it mathematically, that theorem. So what does it shows here? What does it states that you have any system of coplanar, this is a rigid body, and you have different forces P1, P2, P3 acting at points A1, A2, A3 and so on. What we have to do is that all these forces can be reduced to a single force together with a couple. So in that case, let us see the mathematical formula for this. So you have here P1, P2 dash dash Pn be different forces, okay, be the forces, okay, be forces acting on a plane in this rigid body at points A1, A2 dash dash An respectively, which means respectively. So what we have to do is that you take for this rigid body, now we take the line XOX prime, XOX prime, okay, this is O, okay, X prime, and Y prime, two lines perpendicular to each other in the plane of these forces, whereas in the plane of these forces. Now let x1, y1 and x1, y1 be the coordinates of this point A where a force P1 is acting, and let A2 be the coordinates of this point A2 be x2, y2 with in reference to this coordinate axis x or y. And then let forces of this one x2, y2, x3, y3 and so on be the coordinates of this point A1, A2, A3 with respect to the axis. Now what we have to do, let the direction of these forces makes an angle alpha 1. Now if you draw here, draw this line parallel AX, okay, this one and this as y-axis parallel to this axis OX, and this one parallel to the y-axis. So let this force P1 makes an angle alpha 1. Similarly with this force acting P2 acting at A, you can draw two lines perpendicular along OX and along OY. This is alpha 2 makes an angle alpha 2 with the x-axis and so on. So then so what we have to do is now you take these forces P1 at A1, okay, forces P1 and A1, and let X, capital X1 and capital Y1 be the component, the result part of these forces along X and Y direction. So if you have here, this is force P1, okay, acting at A1, which makes an angle alpha with the x-axis, okay. So these forces, the result part of these forces along the x-axis and along the y-axis is given by y1, and along the x-axis it is given to be x1, and along the y-axis it is given to be y1, such that y1 is equal to p1 cos alpha 1. All this result part, it is in unit 2, okay, result part of the forces, component forces along the x and y axis, and x1 here will be equal to p1, okay, this is x1 and this is y1 is equal to p1 sine alpha 1. Similarly, we can find the component forces, all the component forces along OX and OY, that is the component forces of force P2, it is denoted by X2 for this forces P2, this is P1, okay, this is force P2, so it will be denoted by Y2, and this is Y, X2 alpha 2, this is alpha 1, such that Y2 here will be equal to P2 sine alpha 2, and x1 will be equal to p2 cos alpha 2. Similarly, with the rest of the forces P3, the component of all these forces P1, P2, P3 and so on can be resolved along the x and y axis respectively, such that you have this form. Okay, this form of forces along the x-axis, that is x1 is equal to P1 cos alpha 1, y1 is equal to P1 sin alpha 2, y2 is equal to P2 sin alpha 2, x1 will be equal to P2 sin alpha 2 for all their forces. So now let us take this forces P1. Okay, we have this forces P1 at A1. Okay, this is y1 component force. This is P1 alpha 1. This is x1, which has now at O. Okay, at this point O, we introduce two equal and opposite forces. Now along this x-axis, negative y-axis and positive x-axis. So this forces P1 at A1, I am introducing two equal forces, x1 along OX and x1 along OY, such that this forces doesn't have any effect on this whole system of rigid body because they cancel each other. Similarly, along the y-axis also I am introducing y1 along OY, positive direction of y-axis, and y1 along the negative direction x-axis, so that all these forces they cancel each other. Now if you take these forces, see, as this force is P1, as we have seen the coordinate is x1, y1. Okay, so the distance from here, it means that from here to here it is x1, and the distance from here to here it is given to be y1. So if you take, this is force x1, this is P1, okay, force P1, and this is force y1, and this is force, this is the origin O, where you introduce two equal forces, x1, x1, and then y1, y1. So you will see that these forces at A1, okay, with these forces, with this one, such that you have these forces, this is x1 at A1, and then the distance from the origin, this is the origin. Okay, this is O, point O, I am introducing x1, such that these forces and these forces, they constitute a couple, means they form a couple whose distance from here to here is given to be y1. This is y1 and this is x1. So they form a couple whose moment, so therefore this forces x1 at A1 is equivalent to a force x1 along OX in the positive direction, together with a couple, this one, together with a couple whose moment, this one, whose moment is equal to x1, y1. That is sum of either of the forces which form a couples into its perpendicular distance from the line of action of their forces. So as you can see here, now the direction here, it has a tendency to move in this direction. This forces has a tendency to move in this direction, so which means that it is in clockwise direction. So we have minus x1 into y1. Similarly, the forces y1 at A1 is equivalent to two forces, because we are introducing along the y-axis two equal forces, y1 and y1, one along the x and the other along the y-axis, along the positive and negative direction, such that these forces balance each other. So as you can see, these forces, they are like parallel forces, so they will not constitute a couple, whereas these forces with this one, they constitute a couple whose distance from here to here is x1. So therefore this equivalent force, this forces y1 at A1 is equivalent to this forces y1 along the negative direction, positive direction, and together with a couple whose moment is y1 into its perpendicular distance. The distance of these forces from these forces is this one, which is equal to x1, that is x1. And as you can see here, this is x1, so it has a tangent y1, and this is y1, downward. So the distance from here to here is given to be x1. Okay, so it has a tendency or to move in the anti-clockwise direction. So the sign here, it should be positive. So thus the forces here we have here, the forces P1 at A1 whose coordinate is x1, y1, having the result part x1, y1 along the x and y axis is equivalent to the component forces x1 along the x axis or x axis and y1 along the y axis along OY, together with a couple whose moment is equal to this one, what we have seen here, together with a couple whose moment is equal to this, the sum of, it is not here, together with a couple means here y1 x1 minus x1 y x1, small, this is perpendicular, g here is equal to y1 x1 minus x1 y1. So similarly in the same manner for the forces P2 at A2 also, you can reduce it to, all these forces will be equivalent to the forces along OX, will have result to a component force x1 y1 together with a couple whose moment is g, whose moment is equal to y2 x2 minus x2 y2 and so on. So this process will be applied to all the given forces P1, P2, P3 and dash dash. So we now combine all those component forces at O along OX to have a resultant components. We combine all those forces as you have introduced here. x1 you introduce force x2 along y-axis, also you are introducing y1, y2 and so on, the component forces of all the forces P1, P2 along the x and y axis. So we have combined them together such that we have along the x-axis, it will be the sum of the forces along the x-axis, that is x1 plus dash dash plus xn. Along the y-axis, it will be y denoted by y, the resultant forces along the y-axis, that is y1 plus y2 plus dash dash plus yn. And all the couples also acting for these forces P1, P2, the resultant couple is given by G is equal to, for the couples for the forces P1 at A1 is given to be this one, y1 x1 minus x1 y1, and then the couple for the forces P2 is y2 into x2 minus x2 into y2 plus dash dash. Similarly for the other forces P3, P4 and so on. So this can be written or combined together as summation of y1 x1 minus x1 or xi yi into xi yi, where I here varies from 1 to, and that is the resultant couple. Now this resultant couple, this can be written as summation of xi, and this can be written as summation of yi, where I varies from 1 to, and these two forces x and y can be combined together to have by. So if you have the resultant forces along the x-axis is y, and along the x-axis is this, and along the y-axis is this. So the resultant couple of this, the resultant force of the resultant of these two forces can be combined together to get a single resultant, say r, which makes an angle theta, such that r here is equal to, x here is equal to r cos theta, and y is equal to r sin theta, which implies that r square here will be the square root of x square plus y square. Okay, sorry, r will be equal to square root of x square y square, and tan theta here you divide here y by x here will give you tan theta, or theta here will be given as tan inverse of y by x. So thus this given system of forces, coplanar forces acting on a rigid body, is equivalent to a single resultant r all those system, as you can see here, all this system of forces here, as you can see now, forces P1 at A1, P2 is equivalent to a single resultant R, which is equal to square root of x square plus y square, acting at O, which makes an angle theta with the x-axis, together with a couple of moment G is equal to x, a summation of yi xi minus xi yi, which is same as summation of y1 x1 minus x1 y1. So where this summation stands for the sum of all this, that is, if you remove this summation, then you keep on adding all the couples, so, individual couples together here, that is y2 x2 minus x2 y2, and all those. And similarly for the individual couples of the remaining forces P3, P4 and so on. That's all.